All right, so today we're taking a deep dive into this thing called Rheocasting. It's some kind of metal casting technique. And the source we're looking at today, a report from a Chinese manufacturing company. They're saying it could be huge, Like they think it'll totally change how we make everything, from cars to like even smartphones. It's pretty wild.
Yeah, I mean, it does seem like something kind of small at first glance,
Yeah.
but, at its core, Rheocasting is a pretty big shift from traditional die casting. And that small change, that little tweak to the process, could have huge implications for, well, basically everything.
So can you like walk me through it? What makes it different? Why is everyone making such a big deal about it?
Well, the real key here, the thing that makes it special, is the metal. Instead of using, totally melted metal, Rheocasting uses this, well, it's almost like a slurry. It's got solid metal particles, but they're suspended in liquid.
Huh, so it's not like completely melted. Okay, so how does this slurry make stronger parts? Is because the source keeps talking about like amazing quality and incredible strength.
Well, that's where it gets really interesting. When you pour molten metal, it can splash, right? And it can trap air sometimes, and it cools unevenly. All of that ends up creating, like, weak points in the final product. But the slurry, it flows so smoothly and it fills the mold perfectly. That means you end up with a really uniform, strong structure.
Gotcha. So fewer problems and way stronger parts. I mean, that already sounds amazing, but uh,
Yeah.
I noticed the source mentions specific metals, aluminum and magnesium, and even some bronze alloys, they said. What's so special about those?
It really comes down to how those specific metals behave,
Yep.
like how they act when they're in this semi-solid state. Aluminum, for instance, we all know it's already super lightweight, eh? But get this, with Rheocasting, it actually gets even stronger. And that's huge, especially for, well, anything where weight matters. Electric vehicles, for example. Every pound you can shave off, that's more range they get.
Oh, yeah, that makes total sense. So you're saying you can actually make something lighter, but it's also stronger. That's pretty cool. What about magnesium and bronze then? Do they benefit the same way?
Oh, absolutely, yeah. Magnesium is, well, it's another lightweight metal, obviously,
Hmm.
and this whole process, it just makes it that much stronger and more durable, too. And bronze, well, certain bronze alloys, they really benefit from how the slurry solidifies in Rheocasting. The process gives them, like, some really improved properties.
So, okay, let me get this straight. We've got this special slurry, and it goes into the mold, and it solidifies, really evenly, and we end up with these crazy strong but lightweight parts. Is that like is that it? Because I mean, that's already impressive, but the source keeps going on and on about all these
Oh,
benefits.
and we're just getting started. I mean, did you know that Rheocasting, it even gives you excellent weldability?
Really?
Yeah, because the structure of the parts is so tight and uniform, it makes welding them, well, it's just much cleaner, and the welds are much stronger.
So it's easier for manufacturers to work with these parts, basically. That makes a lot of sense. Less hassle for them. Wait, but hold on, there's more, right? The source mentioned something about conductivity too.
Right, right. And that's where things get really interesting, especially when you're thinking about, like, electronics and power systems.
Okay, so what does that even mean?
Well, think about aluminum again. It's already a fantastic conductor, right, for both heat and the electricity. And when you use real casting, well, it actually gets even better at conducting.
No, hold on. Are you saying my phone, like my smartphone, which is probably already using aluminum parts, it could be even better if they made those parts with this process?
It's true, yep. And it's not just phones. I mean, think about it. Electric car batteries, solar panels, anything where energy transfer is important. Rio casting can make them more efficient.
This is blowing my mind, seriously. Okay, so we started with this like metallic milkshake idea, and now we're talking about changing how we build cars, phones, and even batteries. It's crazy. But there's one thing in the source that, I don't know, it's just really jumped out at me. It said that Rio casting often results in parts that need less finishing work, like less grinding and milling and stuff.
Yeah, that's a huge benefit, and a lot of people don't even realize it.
So why is that?
Well, you see, with traditional casting, you get rough edges and imperfections, and you got to smooth those out. It's just, another step in the process.
Yeah.
But Rio casting, you end up with parts that are, well, they're practically finished right out of the mold.
So less waste then, right. And it's probably faster and cheaper too. Sounds like everybody wins.
Mm.
But thinking about all of this, all these benefits, it makes me wonder, like, where is this even being used right now?
The source did mention a few specific industries, so let's get into those.
Well, the big ones they talked about were vehicles, telecom, and power battery tech.
Yeah.
And they all, they benefit in kind of different ways. Okay, so let's start with vehicles. I mean, I can already see how lighter and stronger parts, that's got to be huge, right? Especially with, electric vehicles and all that.
Oh, yeah, for sure. People want these EVs to go further and further on a single charge. And, well, the easiest way to do that is to make the car lighter. But you can't sacrifice safety, obviously. So Rheocasting, it lets manufacturers build lighter parts for the chassis, engine components, even like structural parts for the body. And the best part is they're just as strong or even stronger than, the old die-cast parts.
So it's not just about making cars lighter, it's like making them better all around. Okay, so what about telecom then? How does this all fit in with, phones and all the other gadgets we use?
Well, remember how we were talking about conductivity? About how Rheocasting makes aluminum like a way better conductor? That's super important for this stuff.
Yeah.
I mean, all these modern devices, they need to be shielded from electromagnetic interference. And aluminum, well, it's already good for that, but with Rheocasting, it's even better.
Okay, so you're saying like the parts in my phone, which are probably already aluminum, they could be even better if they were made with Rheocasting.
Exactly. It's all about clear calls, fast data transfer, all that stuff.
Wow. Okay, that's really interesting.
Oh,
What about power and battery tech then? I mean, weight and efficiency are like the biggest things there, right?
yeah, totally. Everyone wants lighter batteries, more powerful batteries,
Yeah.
especially with, everything becoming more and more portable.
Yeah.
And Rheocasting, it can help with that in a couple of ways.
Hmm.
First, like we said, it makes aluminum way more conductive. So that means batteries can, well, they can charge and discharge more efficiently.
So longer battery life, faster charging times, I mean, that would be huge.
Absolutely. And then there's the weight thing, too. Imagine if your phone or your laptop, I mean, if the battery was significantly lighter, but it still had the same amount of power, you know? That's what Rheocasting could do.
I mean, we've gone from talking about a metallic milkshake to like changing how we build entire industries. It's pretty amazing. But you know what really stood out to me in this source? They said that Rheocasting can result in 100% recyclable products.
Oh, yeah. That's,
That's
yeah,
a big one. I mean, 100% recyclable. Is that even possible? Are there any catches there?
well, it's not quite that simple. It depends on a few things, like the specific metals they're using,
Okay.
and if there are any like coatings or other materials, and even the recycling infrastructure itself plays a role.
Right, right. So it's not a perfect solution yet, but still the potential is there, right? If we
Mhm.
can actually, you know, close the loop on manufacturing, use recycled materials and build things that can be recycled later. That's got to be, I mean, that's a huge step towards like actual sustainability.
I totally agree. It's not just about less waste. It's about,
Hmm.
creating a circular economy where we're
Yeah.
constantly reusing and repurposing stuff.
Okay, but here's the thing. If Rheocasting is, if it's this amazing with all these benefits, why aren't more people using it? What's holding it back?
Well, I mean, it's a new technology, right? There's always going to be some hurdles at first. One of the big ones is the cost. Setting up for Rheocasting, it can be a lot more expensive than traditional die casting. You need special equipment, and you need people who know how to use it.
Right, so companies need to be willing to like to invest in it and
Well,
train their people.
exactly. And there's a learning curve too. It takes time to figure out the process and get it right. But as more and more people start using it, the cost should come down, and it'll be easier to find people with the right skills.
So it's like that classic early adopters versus, waiting for everyone else to catch up.
Yeah, pretty much.
But it sounds like the companies that jump in now, they could have a big advantage later.
Oh, absolutely. And you got to think about the innovation side of things too. I mean, as more people research this and more engineers start working with it, we're going to see even more uses for it. I'm sure of it.
It's like we found this hidden gem, this amazing new process, and we're just starting to like scratch the surface of what it can do.
That's a great way to put it.
And it really shows you how like one small change, just changing how you do something, can have such a huge impact. I mean, we started talking about this metallic milkshake, and now we're talking about the future of like manufacturing and sustainability and all this stuff.
It's true, yeah. And I think it's a good reminder that
Hmm.
that innovation, it doesn't always have to be about inventing something completely new.
Mm.
Sometimes it's just about, looking at what we already have and finding ways to make it better.
That's a That's a really good point. And it makes me think, we've talked about cars and phones and batteries, but where LSE could this technology be used? I mean, the source mentioned those industries, but
I feel like there's got to be more, right?
yeah.
I mean, like, what about, I don't know, aerospace? You need lightweight stuff there, right? And it's got to be strong, too.
Exactly, yeah. Imagine, like, airplane parts that are lighter. That means the planes use less fuel, so there are fewer emissions, and they could fly further, too.
Oh, wow. Yeah. That's, that would be huge. What about, medical devices?
Oh, that's a good one.
Mm.
I mean, you could use Rheocasting to make, like,
Yep.
implants that are stronger and more compatible with the body, and surgical instruments, too. They could be, like, way more precise.
Wow, I hadn't even thought about that stuff. But it makes sense. This whole thing is like,
Yeah.
it's kind of mind-blowing, you know? We
Yeah.
started with this metallic milkshake, and now we're talking about like changing how we build airplanes and medical devices.
Pretty amazing, right? It really is. And it just shows you, like, how much potential there is out there and how one little change can make such a big difference.
Yeah, I agree. And I think it's a good reminder for everyone, you know?
Yeah.
Don't be afraid to like dig into something that interests you, even if it seems kind of, technical or complicated at first. You never know what you might find.
Yeah, that's a good point. So to everyone listening, like, keep exploring, keep asking questions, and don't be afraid to, think outside the box. Maybe you'll be the one to discover the next big thing with Rheocasting. Or maybe you'll find something totally new. Who knows? The possibilities are, like, endless, right?
Absolutely.
All right, well, that's it for today's deep dive. Thanks for listening, everyone. And until next time, keep on learning.